Consider this physics question. A magnet is moved through a coil of wire. The EMF produced in the wire depends on dash. A, the number of turns in the coil. B, the strength of the magnet. C, the speed at which the magnet is moved. D, all of the above. And E, none of the above. So this question has to do with electromagnetic induction. So with the help of Faraday's law of electromagnetic induction, you'll be able to answer this question. So the Faraday's law of electromagnetic induction shows the behavior. It shows us the behavior of a magnet when it is moved towards a coil, or when the coil is moved towards the magnet. That is, when there is relative motion between the magnetic field and the electric field. So, for example, if we bring a magnet close to a coil of wire, let's say this is a magnet and this is a coil of wire. So, as you are moving this magnet towards the coil of wire, EMF will be produced in the coil of wire. So, what do we mean by EMF? That's electromotive force. So, you know, electromotive force is the energy needed to drive current. So, around a circuit. So, electromotive force will be produced. Now, as the electromotive force, that electromotive force that is produced depends on certain number of things. So, first of all, from the Faraday's law of electromagnetic induction, we can generate that the electromotive force has the formula negative N d phi dt. So let me interpret each concept. This N stands for the number of turns in the wire, number of turns in the coil, in the electric coil. So this is the number of turns. So it means whenever the number of turns is larger, if you have more turns in the coil, then the electromotive force will be higher. So because there is direct proportionality between them. Then the second one is phi. What do you mean by phi? Phi stands for the flux, the magnetic flux. So what do you mean by magnetic flux? That is the magnetic lines of force. You know, in every magnet, there is only some imaginary lines of force. We can't see them, but it depends on how big the magnet is. If a magnet is small, the magnetic field around the magnet will be small. But if the magnet is big, the magnetic field around the magnet will be large. So for a small magnet, a small magnet will have small magnetic flux. So for a big magnet, we have big magnetic flux. So when the magnetic flux is larger, so it means the EMF will also be larger. So, but another thing, look at this, d phi dt means change in the phi, that is change in the magnetic flux per unit time. That is, if you move this magnetic field faster, if you move it faster, there will be high EMF. But if you move it slower, there will be low EMF. So it means the EMF also depends on the magnetic flux. And then it depends on the speed with which you move the magnetic field. So how many things now? We have N, and we have the magnetic flux, and then we have the speed. So that means option A is correct about this. Option C is also correct because this is talking about speed at which the magnet is moved. Secondly, the number of turns in the coil. So we have that already. Then, how do we now generate the strength of the magnet? So they give us flux. We have magnetic flux. So, but we don't know anything about the strength of the magnet. So the strength of a magnet is always called the magnetic strength. So it's always called the magnetic field strength, or we call it the flux density, and that is denoted with letter B. So there is a relationship between the magnetic flux phi and the flux density B. So because the formula for calculating phi is equal to the magnetic field strength times the area of the coil times cos theta, where A stands for the area of the coil of wire, B stands for the strength of the magnet, and cos theta. This theta stands for the angle between the magnetic field and the electric field. That is theta. So right now we can see that since phi depends on strength of the magnet, definitely the strength of the magnet is also correct about this. So that means since three options are correct, let's see the next option. This say all of the above. Definitely all of the above will be the correct answer. So none of the above, throw away that. All of the above is the correct answer. Thank you. God bless you.